our first speaker on stage, Mr. Wael Moati, gas industry expert with OAPEC. Wael has 19 years of experience in the gas industry. In 2013, Wael was appointed as gas industry expert at OAPEC, where he acts as the chief gas officer responsible for developing and reflecting OAPEC's views and insights on hydrogen, as well as the gas and LNG sector. He is also a member of the United Nations Economic Commission for Europe's group of experts in gas. And Wael, it's a great honor to have you here. May you kindly introduce a bit more about yourself, about OAPEC, and fire up the presentation.
Thanks so much, Molly, for your brief introduction. Good afternoon or good evening, ladies and gentlemen. Allow me first to thank Leader Associate for the kind invitation to OAPEC to share some insights about hydrogen development in the Arab countries. Briefly introducing my organization, OAPEC. OAPEC is a regional intergovernmental organization established in 1968 in the state of Kuwait. OAPEC, like any other organization, intergovernmental one, is keen with enhancing cooperation among its members in various forms of the petroleum industry. OAPEC members are 11, and some members of OAPEC are also OPEC members, but as I mentioned, it's only for the Arab countries. Back again to the main theme of my presentation, I will speak on the hydrogen development in the Arab countries to share together what is the current status and what are the challenges we think it will affect the development of the hydrogen economy, and also what are the future steps in order to advance the hydrogen development in the Arab region. I will speak in my presentations on three parts. In the first part, I will speak or provide some key figures and facts about hydrogen. And in the second part, I will speak in more details about challenges and the potential success factor to develop hydrogen economy in the Arab region. And in the last part, I will speak about the current plans to produce and export hydrogen according to the most recent survey we have conducted here in OAPEC. Hydrogen, like any commodity, has what we call a value chain that consists of three main components. The major component of the value chain is the production side, in which hydrogen is produced using the fossil fuel, as we know, like gray hydrogen produced from natural gas or black hydrogen produced from coal. And also we have what we call renewable hydrogen or green hydrogen that can be produced from electrolysis of water and of course using the renewable energy sources. The second part of the hydrogen value chain is the storage and the transportation part of the value chain, in which hydrogen can be, let's say, stored as a compressed gaseous hydrogen at high pressure of about 350 to 700 bars, or can be liquefied to have a liquefied hydrogen, but it requires to liquefy hydrogen and reduce its temperature to minus 253 degrees. And also for transportations, pipelines can be used to transport hydrogen, or can be used, we can use trailers or tankers to transport either compressed hydrogen or liquid hydrogen. The last part of the hydrogen value chain is the end-use applications. And all of us know that hydrogen has a wide range of applications in which it can be used as a fuel in the power generation sector or in the heat generation sector, and also can be used in transportation sector through the use of hydrogen fuel cells, and also in the industrial sector, which is currently the main application or the main use of hydrogen in 2020. Of course, we are speaking about hydrogen. Sometimes we are, as I mentioned, producing it from fossil fuels. So in such case, we understand it will have emissions. But if we are speaking about green hydrogen, which can be produced through electrolysis of water, we don't have emissions in such a case. Just to understand where we are right now in hydrogen market. Hydrogen market today is really huge. In terms of quantity, the total production of hydrogen today, or according to the recent estimate by IEA, with about 90 million tons per annum. However, about 99% of today's hydrogen production comes from the fossil fuel, where natural gas is the main source of the hydrogen production, accounting for over 75% of the total hydrogen production. The second main source of hydrogen production is coal, accounting for about 23–24% of the total hydrogen production, and the remaining limited share, if we can say that, is from renewable energy sources, which we call the green hydrogen. However, if we look to the future, and we are speaking today about the role of hydrogen as a key component of the future energy system, there are some, let's say, a positive outlook for the demand on hydrogen. And according to a recent study by the Hydrogen Council, the total demand of hydrogen can reach up to 650 million tons per annum in 2050. What does it mean? It means that the current demand of hydrogen is expected over the next 3 decades to increase about 7 to 8 times by 2050. However, we have to consider also what about the current link between production and consumption of the hydrogen value chain. The bad news is that hydrogen infrastructure is still limited. We are speaking here about 4,500 kilometers of the total lengths of the hydrogen pipelines, which if we compare it with natural gas, we can speak about natural gas about 3 million kilometers. We have still very limited infrastructure for hydrogen. And the second bad news, we can say that, is the hydrogen infrastructure is limited, or let's say geographically concentrated in a number of countries like United States and some European countries like Germany or Belgium. So we understand we are at the very beginning of, let's say, a long route to reach a hydrogen economy by 2050, since we have a very limited infrastructure for hydrogen. So the question to be answered today, and this is my first question in this presentation, from where we are able to produce this huge amount of demand or forecasted demand by 2050. I am speaking about from 90 million tons today to about 650 million tons by 2050. I think the key determinants that will answer this question, from which we will produce this hydrogen, it will be based on 3 main factors. The first one is the economics. Of course, we understand the hydrogen produced from fossil fuels is cheaper if we compare it with green hydrogen, in which the cost can reach about $7 per kilogram. However, we have to consider also the emissions and the environmental impact. We are speaking about hydrogen as a key component of the future energy system and its role in the decarbonization, or we can say the energy transition. So if we compare the fossil fuel, we understand coal can produce about 19 kilograms of CO2 per every kilogram of hydrogen produced, while in case of natural gas, it can be reduced to 10 kilograms. And if we consider CCUS technology in order to capture the CO2 emissions produced with hydrogen produced from natural gas, we can reach about 1 kilogram per kilogram of hydrogen. Of course, in case of renewables, we don't have any emissions. That's why we consider it zero carbon hydrogen, and in comparison with natural gas, it's a low carbon hydrogen in case of natural gas. The third determinant or factors that will affect the production, future production of hydrogen, is the commercial scale. And this point actually usually ignored. We have to understand that today's commercial production of electrolyzer is very limited. The total number of units that can produce on annual basis is about 100 units per year, while the maximum capacity of the electrolyzer is about 10 megawatts. So it can be translated to about 1 gigawatt of electrolyzers that can be produced on a commercial scale nowadays. But if we compare this commercial production of electrolyzers used for the production of green hydrogen with the steam methane reforming units that currently produced, there is no comparison. You can say that, because the current production of steam methane reforming units is about 100 units, and the capacity of one unit is 1 gigawatt. So if we would like to make hydrogen a key component of the future energy system, we have to consider all these factors together: the economic part, the emissions part or environmental impact of hydrogen, and the current commercial scale of hydrogen. That's why we are here today to speak about the MENA region and how we can introduce ourselves as a potential key producer and exporter of hydrogen. MENA region, as we can see here, we have a massive gas infrastructure in place in which we can use it to transport or even export hydrogen to the nearby markets. we have a unique geographical locations since we have a proximity to the European market, which will be a potential demand center of hydrogen, and we have also a proximity to the Asian markets, not so far from the Middle East. MENA region also has some success factors, including the long-established economic ties between Arab NOCs and the IOCs. All of us know that Arab region is a key player in the oil and gas market, and we have successfully established long economic ties and strategic ties with the key players and the majors in the market. And the last one, we have the natural gas, which can be used to produce hydrogen, and we have renewable energy sources. And here I would like to focus more about the resources in the Arab region. If we are looking to the renewable energy sources available in the region, we can translate or can understand it through three main figures. The first one is the wind atlas of the world. Arab region has a high wind speed that can reach up to 9 to 11 meters per second, and this is the highest if we compare it to any other region in the world. And in terms of solar radiation, which we can see it on the solar radiation atlas of the world, we can have solar radiation up to 2,200 to 2,500 kilowatt per square meter. And the last one, the sunshine hours. Luckily we have sunshine hours of 3,900 hours. So it can be translated to about 50% of the year we have sunshine hours in the Arab region. So what does it mean? It means that the Arab region has the optimal conditions in terms of solar and wind resources for the green hydrogen production, because if we need to produce green hydrogen, we have to consider the capacity factor of the electrolyzer. I mean, for how much time it will be able to work. So since we have these significant characteristics of our renewable resources, we understand that capacity factor of electrolyzers will be above 60 to 70%. Regarding natural gas, we are already a producer and exporter of natural gas. And here I will provide with you also some figures regarding the cost of producing natural gas or producing hydrogen in the Arab region, and comparing it with Russia or the European Union. If we look to the right-hand side of the presentation, we can see here the cost of blue hydrogen or gray hydrogen ranges between $0.9 to $1.5 per kilogram. And this is the lowest if we compare it to any other region, as I mentioned, like Russia or European Union. On the other side, if you consider the green hydrogen, it will be, of course, more expensive because we are still at very early stage of deployment of green hydrogen. As I mentioned, still the electrolyzer capacity is very limited to 100 megawatts. And this is also another point that I would like to stress here today. Usually, the cost of hydrogen is available in dollar per kilogram, but we have to consider if we compare hydrogen as a commodity with another commodity like natural gas. So on the left hand side of the presentation, I put natural gas for comparison with different types of hydrogen. In case of natural gas here in the Arab region, it costs us about $4 to $5 per million BTU, which is the common unit used to translate the cost of natural gas in the region or even globally. If we consider gray hydrogen, it will increase to about $9 per million BTU. And if we consider blue hydrogen, which is gray hydrogen with the application of CCS or CCUS, so it can reach about $13 per million BTU. And of course, the case of green hydrogen will be the highest, which can be translated to $32 per million BTU. But in all cases, Arab region, if we look to these numbers or figures, we are the lowest if we compare ourselves to any other region in the world. However, are we able to produce hydrogen in commercial quantity to meet the growing or the expected growing demand on hydrogen by 2050? Of course, we have some challenges, not only in the Arab region, but also in every region, since hydrogen is a new, let's say, a new commodity that we would like to make it commercial and competitive with other commodities like natural gas. The first challenge or obstacle is the feasibility and the funding. We understand the hydrogen will require a high capex, high capital cost. And if we look to the kilowatt of installed capacity of the electrolyzer, it costs around $1,000, from $800 to around $1,000 per kilowatt. And of course, as I mentioned, is the hydrogen itself as a commodity is very expensive if we compare it to other commodities like natural gas. And the funding is also another issue because we are speaking here about a potential market, not a real market. So we have to consider it's a big obstacle to provide or to find the funding sources. On the second challenge is the policy and regulations. Here in the Arab region, we still need to have regulations to cover all aspects of a hydrogen economy, including commercial, functional, and safety codes to deal with hydrogen. However, I can say without governmental support, it's quite difficult to develop the hydrogen economy in the Arab region. The third challenge is the technology itself requirement. If we're speaking about the green hydrogen, we are speaking here about a huge water requirements to produce a kilogram of hydrogen. Just to understand the simple figure, we need about 10 liters of demineralized water to produce 1 kilogram of hydrogen. Of course, this is the challenge in a water scarce region like the Arab region. However, we can overcome this problem, as I will show for you in the next slides. High capacity factor is also a big challenge, but as I mentioned, since we have renewable energy sources, we can provide a high capacity factor of 60 to 70% thanks to the renewable energy sources available in the region. Of course, there are some challenges related to storage and the transport of hydrogen because the hydrogen itself has a very low energy density, which means we need a huge area to transport hydrogen, and with the application, of course, of pressure to have a compressed gaseous hydrogen or liquefied hydrogen. Last challenge is the culture and the capacity building because we are dealing here with a new technology. So we need some time, and this can be overcome using training, workshops, and research institutes, and of course with the establishment of R&D program. In the Arab region, on here in the OAPEC, we have a potential strategy in order to scale up the hydrogen economy. In OAPEC, our vision that we can scale up the hydrogen economy in the Arab region through 3 main phases. In the phase number 1, it will be the application of demonstration and the pilot project, which is very important to understand the technology, to develop the knowledge base, and to understand and define the technical challenges. This is very helpful. And already some Arab countries have started this phase to start the demonstration and the pilot project. Of course, here we need the help of the technology providers, the key players in the market, which provide electrolyzers, as an example, like Siemens Energy. The second stage, which will be the main or the backbone to develop hydrogen economy in the region, is what we call the transition phase, in which the blue hydrogen can play a significant role. In this transition stage, blue hydrogen will help us to understand everything regarding the technology itself, and will help us to develop the value chain because, as I mentioned, we need production, transport, and storage, and of course we have the demand, and also we can be able to finalize everything related to regulatory frameworks. It can last for about 5 to 15 years after the first phase, in which we will apply demonstration and the pilot projects. The last stage, which will be after 15 or 20 years from now, in which we can play a key player or play a key role in the global trade of hydrogen, in which we can build a large scale, commercial scale of electrolyzers, exploiting the low cost expected to reduce or to be decreased from $1,000 per kilowatt of installed capacity. It's expected to reach about $400 to $500 by 2030, and even less by 2050. So this is our vision in OAPEC, that we need about 3 stages, starting with the demonstration and the pilot projects phase to last about 5 years, then to the transition phase, and finally in which we will be able to be a key player and the exporter of hydrogen. In fact, many Arab countries have shown their interest to invest in hydrogen production. And here I provide with you the number of Arab countries, but we are not at the same level of hydrogen development. And what is known is called a hydrogen strategy or national hydrogen strategy. Sometimes we are hearing that many countries have announced their national hydrogen strategy, but we have to understand to announce or publish the national hydrogen strategy, it's a process usually starts with establish of R&D programs in order to have a vision why we need to produce hydrogen, how we can produce hydrogen, and then the next two phases of the before publishing the hydrogen national strategy is the roadmap, which identifies the short-term actions needed to deploy hydrogen, and finally the national hydrogen strategy, which evaluates the hydrogen policies with the existing energy policies in any country. I can see here, we in Arab countries, about 10 countries have shown their interest. 3 countries are already preparing their national hydrogen strategy, namely Egypt, Oman, Morocco. 3 or 2 countries are also preparing their hydrogen roadmap, which is the last step before national hydrogen strategy. And there are also some countries that are show interest for hydrogen, which are 5 countries. We have 10 countries that have shown interest, policy interest in producing hydrogen. Many Arab countries also have successfully signed MOUs with different countries on the policy level. Morocco, Tunisia, Saudi Arabia, United Arab Emirates, and Oman have signed MOUs with many countries, including Germany, Japan, Belgium, and this is very important in this phase. And I can just here show for you an important example regarding the significance of Germany as an example. Germany, of course, is a huge market, and the current demand of hydrogen in Germany is about 55 terawatt hour, which is expected to reach 110 terawatt hour per or by 2030. And at that time, Germany will not be able to produce all this amount. So Germany will be a net importer of hydrogen. So dealing with our partners on a win-win situation, so we can produce hydrogen to export them, I think this is very crucial to scale up hydrogen economy in the Arab region. The last part of my presentation, I show for you here the number of announced projects to produce hydrogen in the region. According to our recent survey in OAPEC, there are about 28 projects to produce and export hydrogen announced in the region. Majority of these projects for green hydrogen, including 12 projects for green hydrogen, 6 projects for green ammonia, about 4 projects for blue hydrogen, 4 projects for blue ammonia, and also there are 2 projects to use hydrogen in fuel cells through hydrogen refueling stations announced in Saudi Arabia and the United Arab Emirates. Some key projects, of course, I am sure that all of us know about that, including new project which will have 2 gigawatt electrolyzer fed by 4 gigawatt renewable energy sources to produce about 650 tons of green hydrogen on a daily basis. We have also RWISE project which will produce or plan to produce about 1 million tons of blue ammonia per year. There is also a planned green project in partnership with Siemens, which will have 100 to 200 megawatt electrolyzers. Also, high port project in the DAC, which will have 250 to 500 megawatts in the first phase, fed by 1.3 gigawatt renewable energy sources. Also, there is a green project in Morocco planned in the last year, which will have 100 megawatt electrolyzers. And the last one, and the last country that had joined the club of hydrogen in the Arab region is Mauritania, which announced 2 projects. One of them is the Amman project, which will have 30 gigawatt of electrolyzers. Not only announced plan, but some countries also have already produced hydrogen, like Saudi Arabia and the United Arab Emirates. Saudi Arabia has already shipped the first, let's say, blue ammonia cargo, about 40 tons of ammonia, and successfully captured CO2 for the production of methanol and also for enhanced oil recovery. And also United Arab Emirates over the past few months has shipped 3 cargoes of blue ammonia to 3 Japanese companies. So the momentum started in the region. We are keen to play a key role in the future trade of hydrogen. So to conclude my presentation, I can say for hydrogen to be a key component of the global resilient energy system, we need a large scale hydrogen value chain from production, transportation, and the demand side in order to have, let's say, a competitive commodity like natural gas or oil. Arab region has optimal renewable energy sources for the hydrogen production, and about 70% of the announced project for green hydrogen, green ammonia, and the remaining 30% for blue hydrogen and blue ammonia. We understand that we are at very early stage of development of hydrogen. However, and there are a list of or a set of challenges and the market barriers, but as I mentioned, we can overcome it by taking the necessary actions. And of course, the strategic partnership between Arab region and the other partners, either in Europe or in Asia, is very crucial to scale up the hydrogen sector in the Arab region. So in my opinion here, I can say that Arab region had the optimal, let's say, the optimal conditions and has a great potential to be a key supplier and the exporter of hydrogen in the near future. Thank you, and I'm ready for any question that may arise from our audience. Thank you.
Just one moment, sorry.
That's okay.
Yes, well, thank you very much for your informative presentation. It was a very great one.
Thanks so much, Mo.
Yes, I think there are around 6 questions remaining in the Q&A box, but before we take any field questions, may we go through some of the pre-collected ones first? I will read them to you.
Okay.
Yes, and the first round of questions is always about projects. Is there currently a specific pipeline of projects planned for key countries looking at hydrogen in MENA region? Which countries do you think is leading the wave, and which country do you think holds the most potential?
Well, as we have seen in our OAPEC presentation, we have mentioned that many Arab countries have announced plans to export hydrogen. The good news that we have started the first project in United Arab Emirates in Dubai, which is called Mohammed bin Rashid Solar Park. We have started the first project. Oman, I think it will be the next country in the Gulf region or in the Arab region to produce hydrogen. Egypt also has some, let's say, ambitious plan to produce hydrogen. Saudi Arabia already have announced the large or the mega project of NEOM. So I can say we have started, by the way, to produce green hydrogen, as I mentioned, in Dubai. But over the next 4 to 5 years, we will have some projects which will come on stream, commercial project or commercial industrial project, starting from Oman, United Arab Emirates, Saudi Arabia, maybe by 2027, and also in Egypt. Morocco also is another example in which the European countries have looked to the Morocco, taking into account the proximity to the European market, and they have agreement with the German government in this regard.
Yes, and you talk about some ground activities already going on right now. Despite big talks, when can we expect the first gigawatt green hydrogen production be operational in MENA?
I think the first gigawatt project will be in Oman, maybe high port in Oman. The project will have in its initial or first phase about 500 megawatts, fed by 1.3 gigawatt renewable energy sources. So I think this project will be the first one to be commercialized, to be materialized and to produce hydrogen. The second project will be also most properly in Oman, because Oman will has, by the way, about 7 projects planned project for green hydrogen. There are also some another projects which are blue hydrogen. One of them is planned in Egypt by Eni. So we can expect over the next 5 years, we will have many projects come, especially from Oman, Egypt, and United Arab Emirates also.
Very good, very good. And the third question is actually from me personally. It's a problem that keeps me awake in the night. So the water scarcity problem. You touched a bit on this issue, but can you elaborate more on that? Where and how can we avail water from H2 electrolysis in MENA, and at what cost?
This is actually a very important question, in my opinion, and also a significant challenge to develop or to scale up hydrogen, green hydrogen economy in the Arab region. Arab region is a water scarce region. We don't have, let's say, fresh water resources, even not enough for drinking purposes. But if we consider the seawater and consider desalination of the seawater, we can feed the electrolyzers. Of course, we will speak here about extra costs that we will use to desalt the seawater. According to the commercial figures from the key companies in the market, the desalination, if we consider it an extra cost, will increase the cost by about 5%. So we have the water sources, unfortunately not the fresh one, but we have the seawater. But if we consider the extra port, it will increase about by 5%. But at the end of the day, we still very competitive if we compare the cost of green hydrogen here in the Middle East, which is around $3 to $4 per kilogram. If we compare it to about 7 to 8 kilogram in Europe, even they have the renewable energy, so even they have the freshwater sources, but they don't have the renewable energy sources, which will guarantee a high capacity factor. So I agree with you, it's a big challenge, but at the end, we can translate it into cost. And at the end, we are competitive. That's why many countries, many European countries are keen to partnership with the Arabian countries like Germany, Belgium, and even United Kingdom. Over the past 1 week, there is also some plans to partnership with the United Arab Emirates.
Great, very well. And one last question before we take field questions. You just gave a very comprehensive introduction about the successful factors and the challenges that MENA region is facing right now. Can you name the top 3 successful factors and the top 3 obstacles when it comes to scaling up the hydrogen production and the trade in MENA or in individual markets?
First one, the resources, which is the feed of the hydrogen. Renewable energy sources, we have it. And as I said, it will provide us with a high capacity factor of electrolyzers. And in case of natural gas, we have also natural gas, which can be used to produce gray hydrogen. And with the application of CCUS, we will have blue hydrogen, which is also accepted by the international community. Second one is the governmental will. And this is very important to advance or to scale up the hydrogen economy in the Arab region. Without governmental support, we cannot expect that hydrogen will be, let's say, a common reality or a reality in the future. And as we can see from our presentations, that the major oil producers or producing countries are the leaders of the hydrogen plants in the region, like Saudi Arabia, United Arab Emirates, Oman. So all of them are key. So the third factor that we have some infrastructure for natural gas that can be used to transport and export hydrogen. So renewable energy sources and natural gas resources, governmental will, and also the network or the infrastructures that can be used to transport and export hydrogen. The 3 main obstacles, in my opinion, again, is the regulations, the part, which is very important. We are still dealing with new technology. Funding, till now, all the funding are from the major state oil companies here in the Arab region in partnership with the oil majors. So funding is still a big challenge, even that we have a list of projects, as I mentioned. And the last one, as I told you, is the water resources that need for the electrolyzers. But of course, with continuous R&D, we expect that the cost of producing green hydrogen could be lower, and the installed capacity, I mean the capex of the installed capacity, is expected to reduce by 60% over the next 2 decades.
Very well. And if possible, may you kindly open your Q&A box and check the remaining questions in the open column. We will take the first 3. So the first one, do you think there will be a conflict both politically and economically between EV and H2 for transport sectors? It's more into the demand side management.
Again, sorry, between, can I read the question? A conflict between?
Okay, a conflict between EV and H2 for transport sector.
Okay, EV
means electric vehicles, for example, like battery-based vehicles, okay, and hydrogen fuel-based vehicles.
No, in my opinion, we are here, by the way, speaking about the Arab region and the producer and the exporter of hydrogen. We still have very limited applications. As I mentioned, only 2 projects, one in Saudi Arabia and the second one was in United Arab Emirates. But they can complement each other. I mean, they can not, it's not a competition between electrical vehicles, EVs, or fuel cell electrical vehicles. And by the way, we have also to emphasize here, the main sector to consume hydrogen in the future will be the transportation sector. because about 28% of the total demand of hydrogen by 2050 will come from the transportation sector. So we have to understand, we are still at very early stage of development, but transportation sector, and there are some countries, some European countries already started to have trains running on fuel cell electric, on the fuel cell. They have also some plans, some targets. According to our studies here in OAPEC, about 11 million fuel cell electrical vehicles are expected to be on the road by 2030. So I don't think it will be a conflict. It maybe they may complete each other. And of course, we need both of them if you would consider to decarbonize the hard to abate the transportation sector.
Yes, great. And another question with regards to supply chain, I think, from Sukania. Good afternoon. I would like to know if there's already an industrial ecosystem in Arab countries that can be utilized in developing hydrogen projects. It's more like the supply chain issue, the infrastructure associated, as well as I think it will be the local content with regards to developing hydrogen projects in the region.
Well, as I mentioned, we need in this phase, we need to partner with the international players in the market. And that's why there is no single project has been announced by the local content in the Arab region. In all projects, we have a sort of partnership with the key players in the market, like Siemens Energy, like DEME, Belgian DEME company, even some Indian company. I think we will have the CEO of ACME or ACME company, which has a project in Oman. So regarding, to start with the local content, we are speaking about a very new technology to produce it. Regarding, if I can remember the question, the hydrogen value chain or the infrastructure, I think is the most available option and the most viable one to export the hydrogen from the Middle East will be ammonia tankers. And there are a list of Arab countries, especially in the Gulf region, have announced to produce ammonia and to export it using ammonia tankers in order to reach far regions or like the Asian markets. So in my opinion, we have to produce hydrogen and consider the ammonia as a transportation and the most viable option to export hydrogen from the Middle East. And we have from North African countries like Libya, Algeria, we have, by the way, export the gas pipelines already existing and have a total capacity of 65 BCM annually of natural gas, in which we can use them to have a hydrogen blend with natural gas, and we can assess the capability to transport the pure hydrogen, I mean 100% hydrogen using this existing infrastructure. That's why we are in a very good position if we compare ourselves to any other region, since we have the resources, we have the infrastructure, and we can consider the ammonia tankers as an option to produce and export green hydrogen, green ammonia.
Right, great. And one last question before the session ends. So do you think from top down, do you think MENA states will play a central part in efforts to develop international certification schemes for blue and green hydrogen projects? Because MENA is expected to be one of the leading region for hydrogen production and export. Do you think there's some policy frameworks or programs that are being discussed right now?
Already started in United Arab Emirates, and thanks for the question from our colleague from the audience. Already started in the United Arab Emirates to consider regulatory framework. But again, as I told you, we are still at a very early stage. But United Arab Emirates has already announced, let's say, the safety codes, safety and risks code for the use and dealing with hydrogen. And in such phase, which we are now, we need cooperation among Arab countries themselves. So if United Arab Emirates has already taken some advanced steps, I think with cooperation, even under the umbrella of a OAPEC organization, we can have a mutual, let's say, a policy or a regulatory framework to exploit or to invest in hydrogen. So I think, again, I repeat, I emphasize that MENA region, since we are keen at the governmental level to be a key player in the market to produce and export hydrogen, either blue hydrogen, blue ammonia, green hydrogen, green ammonia, we will have to develop the regulatory framework and to develop also policies. And just to conclude also my answer, as I told you, 5 Arab countries are now in the national roadmap or national hydrogen strategy, are in progress. And there is another 5 countries. By the way, we are total 22 countries. So about 10 countries now are taking, let's say, concrete policy actions to consider hydrogen as a key component of their, let's say, export portfolio of commodities like oil and gas. So we are on the right way, and we have to consider we need still some time. So I am just giving some figures here to speak about. We need 1 to 2 decades until we be a key players in the global trade of hydrogen.
That'd be great. And as you know, there are 9 remaining questions in the Q&A box, but we don't have time for that. I'd like to firstly say thank you to Wael for joining us and for this wonderful presentation. And it would be highly appreciated if you can stay and address some of the questions in the Q&A box.
Thanks so much again for your kind invitation to OAPEC, and hopefully we will have a sort of cooperation in the near future in person in your future events. Thanks so much.
Yeah, thank you.